Welcome everyone. This is the 5th session of the IBIS Prep SAT crash course, and we were going to do writing today, but we took a poll of the class and it seemed that math was actually the subject that people had the most questions and wanted to do the most review for. So without further ado, we're going to jump right into the material. And Jesse, you have a question that we can start with?
Yes. So really quickly, before we start answering actual questions, I just wanted to do a brief review of kind of what topics you're going to see in the math section, okay? Just so we kind of know what to expect, know what formulas to be comfortable with and familiar with, and just kind of how we like approach each of these different topics. So the first and the most important one, this is one that's going to work through every single question, if not all, then most, sorry. And that's going to be algebra. Okay, so that's going to be like y equals mx plus b, factoring, solving for x, all of these things involving a letter of some kind, whether that's x, y, we see above p, right? So any letter that is considered to be algebra, okay? The next one is going to be geometry. So that's like SOHCAHTOA, our volume, area formulas, and then our Pythagorean theorem, right? A squared plus b squared equals c squared. The last thing, and kind of the smallest, least common, is going to be like statistics. So, mean, median, maybe something on probability. Oops. Okay, but it's important to remember that algebra is going to work its way into most questions that we see. Okay, so just keeping that in mind, making sure that you're doing a lot of algebra problems for practice, and getting really comfortable with those concepts, okay? So let's go into a question, and I was thinking of starting with question number 3. So this one is imaginary numbers, okay? And a lot of the times, imaginary numbers are kind of freaky because they're not real, they're fake, right? So people see this and they kind of get scared when they especially see this identity here. But really, we can just think of this imaginary number I like a variable. So it's asking for the sum of the complex numbers 2 plus 3i and 4 plus 8i. So it's a sum, so we can just add them, right? Okay, so here we have to combine like terms. So can anyone tell me what this is going to be when we combine the like terms?
A 6 plus 11i.
Good. Right? So in this case, this is as far as we can take it, okay? And we can see our answer is going to be C. Now, there might be times where instead of this, we'll have 11i squared, for example. Now, if I equals square root of -1, then what is I squared? Can anyone tell me? Anyone know? I squared? It's going to be -1. Okay? Right? When we square both sides, that little root cancels and we end up with -1. So this is kind of why this is that imaginary number. This is that identity that gives us imaginary. Okay.
Can we go over that a little bit more slowly? So what's the square root? I mean, how did you come up with that? That the square root of -1 then I squared equals -1. Could you draw it out or?
So if I equals the square root of -1, then anything we do to one side of the equal, we have to do to the other side. Okay, so we can raise both sides to the second power, right? Squaring both sides. So on the left, we get I squared. And then on the right, this root and this square right here, they'll cancel each other out. So we're just left with whatever is inside, which is -1.
Beautiful.
Again, this might seem weird. This might seem scary. This is just because it's the imaginary number. This is just simply an identity. So something you just kind of have to accept as fact. Okay.
Does anyone have any questions about that one? Because that was a hard question, I think. Everyone would get C on that question?
So to kind of build off my hypothetical, right? So if we had 6 plus 11i squared, this isn't the answer. This would not be our final answer. And why is that? Because we can simplify it. We can still simplify even more than this. How do we do that? Well, we just plug in our I squared value. So can anyone tell me what this is going to be once we plug in that I squared?
-5.
Right? 6 minus 11, -5. Okay.
Cool.
All right. So I guess while we're on the idea or the subject of imaginary numbers, just like for your own practice, I want you guys to find these values and see if there's a pattern that results. Okay, if I is root -1, what is I squared? What is I to the third, I to the fourth? Just keep going until you find a pattern. Okay, that's just good practice for you, because there is a pattern and you should be able to recognize it. Okay.
Well, just for the viewers at home, can you show us the recognizable pattern?
Okay, so we know I squared, that's going to be -1. I to the third, we can think of as I times I squared, right? Which is negative square root of -1. I to the fourth, we can think of as I squared times I squared.
Ooh, I'm starting to see a pattern.
Oops. So in case you don't notice the pattern, it goes in intervals of 4. So it starts every every fifth term is going to be square root of -1. And then we go to -1. Then we go to negative root -1. Then we go to 1. And then the cycle repeats.
Cool.
So that.
Yeah, I like that.
All right.
What you got next? Some graphs?
All right. So we got some graphs next. I'm going to be real with y'all. Graphing questions should be like freebies. These are questions that you should not be getting wrong, because
Cool.
everything is right there. You don't really have to solve anything. Maybe you have to like write a couple things down, but there's nothing to solve. Graphing is just looking, okay?
Yeah.
So in this equation, right, we have y equals 2x minus 5. Now, what is our slope? Can someone tell me? I'll give you a hint.
Rise over run.
Well, the mx plus b, right?
So
Is it 2/5?
Not quite. It's even easier than that. So here, right?
yeah,
Looking,
someone. I think Cole said 2.
it's just gonna be 2.
Yeah, that's what someone in the class said that.
Oh, I heard 2/5. Sorry. Okay. Well, anyway, right? So the way that we're kind of basing our graph is all around this equation here. Y equals mx plus b. This is like the holy grail of graphing equations, okay? And the reason is it's super easy to read. We have our first piece, which is m, and that tells us the slope.
Rise over run.
Then we have the next part, which is b, and that tells us the y-intercept, right? Or we can also think of this as the point 0, b.
Right. Where it crosses the y-axis.
Exactly. Okay. So, well, it tells us the slope and the intercept. That's why this is called slope-intercept form. Okay. This you need to know like the back of your hand. Okay. Like I said, holy grail. So let's relate this mx plus b to what we're given. Okay. 2x minus 5. Well, we can see what is the coefficient in front of the x term. What's that m? Like we said, 2.
Mhm.
And then our b, the add-on right at the end, that's going to be -5.
Right.
Okay, so right off the bat, we know we have a positive slope, so we can cross out b.
Right.
Next, we're looking for that y-intercept, 0, -5. Well, we can cross out A. We can cross out C. So there we go, right? Tells us our answer is D.
Exactly. And what you can see is the slope is 2 over 1, the rise over run. Every point goes up 2 over 1, up 2 over 1. Yep.
Yeah.
And that's the m. The m is the slope, and then the b is the slope intercept, that -5, where it intercepts the y-axis. You're right, Jesse. These are questions that everyone should get right just by process of elimination.
Hmm?
And
So,
when you said a positive slope, Jesse, what did you mean by that exactly?
so positive slope means that if you were to move to the right 1 unit, you would go up. So positive slope, you're always moving like left to right, just like how we read. You read graphs the same way you read a book.
Right.
So if you move to the right 1 unit, a positive slope will go up, a negative slope will go down.
So positive slope is like English and negative slope is like Hebrew.
Exactly. Does that make sense?
No, but before that it made sense. We get slope intercept form is the holy grail, as you were saying. And a lot of times you'll see equations that are not in that form, and you could rearrange them in that form, and then you can graph it, and that's instructive, right?
Yes. Yeah. So part of the skill there is knowing this format so that you can manipulate things and get there yourself if it's not given to you. All right. Oh, what is happening? Okay. So another problem they love to give, this is still algebra, right? We still are like plugging in things, is they'll give you an equation and then they'll give you an expression. So remember, an equation has an equal sign. An expression does not have an equal sign. Okay, so these are equations. This is an expression. Anyway, so they'll give you an equation and then they'll ask for the value of an expression. These are so common, these types of questions. And pretty much 100% of the time, your strategy or your goal is going to be to manipulate and try to plug in to expression. Right? So if it's asking for the value of something, your goal is to try to plug in some value to that expression. Okay. All right. So here it gives us x is 2/3 y is 18. What is the value of 2x minus 3? Well, we know we need to find out what x is. And to find out what x is, we have to plug in y. So we start by plugging that in. Can anyone tell me what this is? 2/3 times 18. Yeah, right? So remember that when we're multiplying like fractions, sometimes it's easier to think of it like this, 18/1. And then we can try to simplify. So how many times does 3 go into 18? 6. 2 times 6. Oh. Okay. All right, good. So we have x is 12. Now it's asking for the value of 2x minus 3, right? So we got to put that back in here. Really, really important. We solved for x, right? But we're not done. We still have to figure out this last piece. A lot of very common mistake a lot of people make is, oh, they'll just say, oh, x 12. That's wrong. Okay, so just be careful. Okay, so write 2x minus 3, 2 times 12 minus 3. What is this?
21.
Gotta make sure
Can you do something for me?
Yes, exactly. So yes, whenever you see an expression, just try to plug in as much as you can.
Yeah, and what Jesse's saying there is crucial. On the standardized tests, so many mistakes are made because of careless errors, not because you don't know how to do the problem. A lot of people there would have done what Jesse alluded to. They would have solved and figured out that x equals 12, but they weren't asking what x equals. They're asking what's the value of 2x minus 3. So always make sure that you are answering the question being asked. And that little bit of consciousness and carefulness goes a long way on the SAT, because every single question, a single mistake is a wrong answer, and you really can't afford that. So really great point, Jesse, to just make sure that you're not just solving for a variable, you're answering the question being asked.
Yeah.
All right, let's do some bricklaying formulas.
Okay, so a bricklayer uses the formula N equals 7LH to estimate the number of bricks N needed to build a wall that is L feet long and H feet high. Which of the following correctly expresses L in terms of N and H? Well, whenever I see a word problem, this might just be like out of habit. Maybe this doesn't work for everyone, but I just like to kind of draw out what they're giving me. Word problems can give you a lot of information all at once. So to just like visualize it can be pretty helpful sometimes. So we know we're building some kind of brick wall. Okay, so let's draw that wall. Let's see what we are dealing with. So we know it's L feet long and H feet high. Okay, so it's asking which of the following correctly expresses L in terms of N and H. So whenever it says this, something in terms of something else, you basically want to get L by itself on one side of the equal sign. That's pretty much all it means. Get L by itself on one side of the equal sign, move everything else however you need to make that happen. So our equation here is N equals 7 times LH. Let me make that a little. Okay, so any ideas here? How can we get L by itself?
Well, what if we divide it by?
Good. Right, we can divide both sides by 7H, and then it's pretty straightforward. We have N over 7H equals L. That's it.
That's it.
Mm-hmm. So this one is pretty simple. Did we need that drawing? Not really. Okay, that's okay. Took us 2 seconds.
Any questions so far?
Yeah.
So far, does everyone feel like the questions we've done, they would have gotten correct, or is there any that have given difficulty?
No, the biggest thing is just making sure I choose the right answer and don't make a stupid little mistake.
Right? You and all your peers. I mean, not all your peers. Some of them don't even know how to do the math. So at least you know how to do the math. But exactly, the next thing is making sure you're careful to select the correct answer, because it's a shame when you do 90% of the work properly and then one careless mistake at the end, it counts just as wrong as everyone else. So it's good to take note of that. But it's also good that so far there hasn't been any math that's been above your head. You know, you've understood all the math so far. So you know what to do, to be careful.
And also silly mistakes, like that can be something that's like fixed. You know what I mean? There are a lot of things like being horrid at math. You can only do so many math problems before you plateau. You know what I mean? So like silly mistakes, like even rushing, that's something you can work on, working on your pacing, working on reading the questions through. Like that's a very trainable skill. You know what I mean? Okay. Let's do number 9. And kind of like building on the last question, we're also going to see this in this problem. People often psych themselves out with math because a lot of people think that, oh my gosh, like this is the most difficult section, this is the hardest one, I really have to rush. And so they think that a lot of the problems are more difficult than they actually are. So,
well, Jesse, this is one of those problems where I think there's a million ways to answer this, right? Mm-hmm. And that's why I really brought you in to run this course, because I think you are the best math instructor on the staff. And what are some thoughts about that? Like, when you see this question, how do you know to do what you're about to do? I know it's very instinctive for you at this point, but like, how would someone like us, a normal person, know what's the best approach? Because at some point it's like, should I just start plugging in answers? Should I I know what the square root of 9 and the square root of 64 are. Should I just solve that? Like, how do you know to do what you're about to do?
So in this case, right, we see a whole bunch of roots. They're all separate. So this looks pretty ugly. In my head, whenever you see separated roots, always try to simplify. So if it was like x plus 9 equals root 64, that would be a very different problem. Okay, But in this case, we know we're solving for x, so I'm just going to solve it like any other algebra problem without roots, and just get x by itself to one side. That's like a decent start
Isolation, yeah.
for like any kind of problem. So we have root 64 minus root 9.
Just to slow that down, I think that's extremely instructive. That her instinct is to isolate the variable to one side of the equal sign. And that was just like, there's a lot of different ways to go about it, but right away she was like, all the variables are isolated. There are none that are stuck together. We could put the x by itself. Seems like a good approach, right?
Yeah, exactly, right? So in anything that we're solving for, like, we're gonna need x by itself at some point, so might as well make that our first step. Just simplify things. Okay.
Nice.
So now looking at this, we see we can simplify those roots. We know root 64, we know square root of 9. Those are whole numbers, they're integers. So let's do that. If they weren't whole numbers, this would probably be a pretty different problem and it would probably take a different approach. But in this case, they're whole numbers. Let's simplify it down. So once you get x by itself on one side, your next step, try to simplify. Root x, okay, root 64 is 8. Root 9 is 3. Okay. Now what? This is not an answer. It's asking for the value of x, not square root of x. So just like we did, a few problems ago, the way that we cancel this out is by squaring both sides. Right?
Easy.
So on the left, we get x. On the right, we get 25, and that is our answer. So none of the math here is really that difficult. Simplifying radicals, like algebra problem. But I think it's important to just like I said, not psych yourself out, not hype things up to be more complicated than they really are.
Totally.
7.
That question.
7 was pretty straightforward. 9 is pretty straightforward, but you might spend way too much time because you think in your head, oh my gosh, this must be wrong. Like there's no way it was that simple.
Well, I think what makes you such a great mathematician, Jesse, is your confidence. Because number 9, a lot of people would see, and like you said, they would be a little bit deterred that it seems difficult because there's radicals, there's variables. How am I supposed to work with all this? But you just simply had an approach. Isolate the variable, simplify the radicals, square both sides, arrive at the answer. There was no fear. There was no uncertainty. It was just a very mathematical process. You went step by step, arrived at the answer, and that's really what math comes down to. That's why I think it's easier to score an 800 on math than it is on reading, because reading has some subjectivity to it in terms of, was the author trying to say this or trying to say that? I'm not really sure. Whereas in math, if you just go very methodically through the math, you're going to arrive at the right answer. And the biggest problem people have is self-doubt. They think they don't know how to arrive at it, but you didn't use any calculus there. You simply just used arithmetic and came to the proper conclusion. So confidence is definitely the biggest piece. And everyone out here who's watching, if you've gone through math in your school, you've gone through algebra and geometry, you should feel confident. There's nothing tested on the SAT except for maybe a few, areas of trigonometry on the, 750 to 800 level, but up to 650, 700 in math, it's all basic geometry and algebra. And it's all about, can you do it quickly, confidently, and mistake-free? There's nothing too difficult. So maybe this question will prove me wrong, but just by looking at it, it seems like arithmetic.
Arithmetic, not so much. More like algebra, inequalities. Again, more algebra. It's all algebra. This whole test is algebra. So
right. And I'm not trying to demean algebra by calling it arithmetic, but a lot of algebra is not difficult. It's just, doing each piece one by one. So you're right, this is algebra, but it's not algebra 2 or 3. It's pretty basic algebra, and we just need to get the answer right. But I do know inequalities can be a little bit tricky, Jesse. So we're paying attention here.
Okay, so Jamie is preparing for a bike race. His goal is to bike an average of 280 miles per week, at least, for 4 weeks. He biked 240 miles the first week, 310 the second week, and 320 the third week. Which inequality can be used to represent the number of miles Jamie could bike in the 4th week to meet his goal? Okay. Again, word problem. Let's take this one thing at a time. Sometimes I don't even like to read the question until I kind of digest the first few lines of information, just because if you jump the gun, sometimes you retroactively will have trouble understanding how that information pieces together. So let's just start with this first sentence or second sentence here, right? This little piece. Okay, so he needed to bike an average of at least 280 miles for 4 weeks. So let's just set up our formula for an average. So let's not even look at our answers yet. We know an average or a mean is all of the things added together divided by however many there are. So up top, we're gonna put the number of miles that he biked each week. On the bottom, we're gonna put 4. There's 4 weeks. So we have 240 plus 310 plus 320, and then we can say plus x, right? We're gonna let x represent that 4th week, the number of miles. Okay, so we do all of that over 4 for 4 weeks. Now going back, his goal was to average at least 280 per week. So we need this average to be greater than or equal to 280 miles, right? So this eats the 280. Okay, so this is kind of how we've set it up. Now we need to see, all right, how can we manipulate it? What can we do to this to try to match one of our answers here? Okay, so first we look at A. We can basically just cancel that out. Totally different denominators. Changing a numerator isn't that hard, but changing a denominator is very difficult. That's not going to lead us anywhere. So let's cancel that out. Okay, looking then at B. Well, they have x being multiplied by 280. Well, okay, let's see some of the manipulations that we can do down here. First, maybe getting rid of our denominator, right? Multiplying everything by 4 will lead us with this. Okay. So again, not quite B, but we can look at our answers and see, oh, this represents answer D, right? It's the same thing. So even though we were able to set up that average inequality situation, we still weren't done. We still had to do some manipulation before we got there. So with these kinds of problems, when it asks what is the equation, there's kind of 2 paths you might take. So the first path is setting up in a way that you know, in a way that you recognize, right? Using one of those mx plus b formulas or this average formula, right? Setting it up in the way that you recognize and then manipulating it to try to match. The second path is it's already done, right? You don't need any manipulation. It's just directly the answer. So just something to keep in mind. Okay, does anyone have any questions about that problem? How do we feel about it? Give me a thumbs up. React. That was
I think those, yeah, those problems are manageable. It's just like you said, manipulation, and I think that's a key word to use in math, because a lot of times math is not about solving; it's more about manipulation, turning equations into simplified versions that you could use to your advantage. And sometimes it's not even a simplified version. Sometimes it's just a version that fits the structure that you're trying to find. So really great job with that question. I think we got thumbs up from the audiences. Ooh, seeing some triangles. I'm a big fan of triangles.
I'm trying to think
No
which one we
triangles.
do.
I kind of like 18. All right, never mind.
Nah, I don't like 18. Sorry.
All right, fine. What number did you pick?
Let's do 16 and 17. Exponents and fractions are something that we have not really worked a ton on. So let's do those. Okay.
For the record, I didn't really like 18 either. I thought that was a pretty dumb question. No reason to do 18, stupid triangle.
Yeah, no, try to both of them. Okay. If a to the b over 4 equals 16 for positive integers a and b, what is one possible value of b? Wow. Okay.
What happened to my answer choices?
Yes. So this kind of problem you'll probably look at and be like, what the hell is this saying?
If
Like,
sorry, I had to do it. I had to read it to myself.
Yeah. So first of all, thing number one, it has 2 variables and only 1 equation. That's always a red flag, because we kind of know in our heads you need the same number of equations and variables. So that's kind of alarming.
And when you say that, Jesse, you're referring to like a substitution problem, where if you have 2 variables and 2 equations, you can properly substitute. But here we have 2 variables and 1 equation, so there's no possible substitution. So we're gonna have to think outside the box.
So kind of like a genuinely, like, the best way to solve this is to guess and check.
Yeah, I was gonna say, just plug in the number.
There are not many times where I will recommend guess and check over something else, but in this case, it's really the only way to solve something like this.
And I want to harp on that real quickly, Jesse, because a difference between Jesse and some other people who consider themselves good at math is a lot of people guess and check first instinct. You see Jesse guess and checks last instinct, because usually she has a bona fide not shortcut, but most effective way of getting to the problem, a straight line way. Guessing and checking is going to be not conducive to time efficiency, but she does recognize there are problems like this one where there's really, and the only reason she was able to accept that was because of her knowledge of math and understanding of the 2 variable 1 equation principle. And she said, okay, because there's 2 variables in 1 equation, there's not going to be a substitution or anything that will help me solve the problem most efficiently. I'm going to have to guess and check. But even so, she's going to choose numbers strategically, right? You're not just going to pick 743. Like, why are you going to pick the number that you're about to guess? Is there any insight, Sarah?
Yes. So let's break this down. I'm going to write it nice and big. Okay. So I would suggest the first variable that we should pick is going to be b. Okay. Choose this one first. Now, how do we choose b strategically? Well, we see b is going to be some positive integer, right? Some positive whole number divided by 4. well, we're not going to choose 3, right? We don't want fractions. We don't want to deal with fractions in our life. Let's make this a 4, an 8, maybe a 12, right? Let's just make this a number that's going to give us a nice round number, okay? So for example, let's say b equals 4. Then when we plug that in, get a to the 4 over 4 equals 16, or a to the 1 equals 16, or a equals 16, right? So we chose we chose b as 4 strategically, gave us a really simple answer for a. There was literally no solving that needed to be done other than 4 divided by 4. Okay. So this is one possible answer, right? One possible correct answer would be b equals 4, a equals 16. Well, what if you wanted something else? Are there other options? Yes. It's actually interesting. There are infinitely many possible values. Just to, are there? No, I guess it's positive integers. No, there's not. Okay, so what if we said, I don't know, just to like show you, what if we said b is, I don't know, 5? Okay. Then we would have a to the 5 over 4 equals 16, and we would have to solve that. Not the end of the world. We can do this and say a equals 16 to the 4 over 5. Is this a whole positive integer? Any ideas? It's not. We see a fraction. There's ways we can solve that, but if you see the fraction in your head, you should just kind of know, let's avoid this one. Looking for positive integers, whole numbers, just make life easier on yourself. Let's avoid the fractions.
Mm-hmm.
Right, so that's kind of why you can see, okay, b equals 4, that's definitely the best choice. That's the easiest choice. Alternative option would be b equals 8, a equals 4.
Could you try just wondering if b were to equal 0?
That's not a positive integer.
Good solution, right? So it has to be a positive integer, it can't be 0, because obviously 0 would be the easiest, but positive integer 4 is the most logical. Or
well, also 0 wouldn't work because anything to the 0 power is going to equal 1. So it wouldn't even equal 16. There would be no solution for that.
No solution. So you had to do something above 0, and then you would do a multiple of 4 just because it was a fraction over 4.
Mm-hmm.
So Jesse, I know we're running out of time, but if you please wouldn't mind for the audience, could we do question number 17?
Yes.
Awesome.
Real quick. Fractions. Fractions are fun.
I know, I agree. Did you know that a division sign is just a fraction with periods replacing the numbers?
I didn't know that.
I saw it on a meme.
Yeah.
But isn't it true? Like a division sign is just a fraction with dots instead of numbers?
Yeah. I guess I'm because it's like
mind blown or no?
Yeah, mind blown.
All right.
Okay.
Does anyone in the class, have an idea about the best approach to this one?
Or maybe you want to try to walk me through it.
I know it's late out there, so I'm thinking cross multiplication, right?
there's an even easier way to do this.
See, that's why I love Jesse. What's the easiest way? Because I would cross multiply, but what would you do that's even easier?
Well, we want t by itself.
Right?
So really all we have to do is multiply both sides by the reciprocal.
Wow. Brilliant.
So over here is going to cancel, and we're just left with t. And then on the right side, well, we see the 2's cancel. We just have 5 over here.
And why are you able to multiply both sides by the reciprocal?
So essentially, like, multiplying both sides by the same thing is almost like multiplying by 1, right? When we think of like a fraction or something, how we can multiply the numerator and denominator.
Well, did you mean that they're both 2 over 3 and one's 3 over 2?
You're so right. I made a mistake.
Okay, good. Yeah, sorry.
I didn't even realize that. Thank you.
No,
Okay,
fine.
3 over 2.
I
I was like, what? Yeah, so when we multiply fractions, remember we multiply whatever's in the numerator and then whatever's in the denominator. So here we do 5 times 3. What is 5 times 3?
15.
Over
4. So what I think is that everyone out there is tired. No one's paying attention anyway because I asked the audience. But, key point there, when you're taking the SAT, finish strong. I always tell people I consider myself somewhat an athlete. So if you're running a race, run through the finish line, always finish strong. And I know we all get tired out there. And even Jesse, the best mathematician on my staff, can still, be a little make a silly mistake. And but when I asked her about it, she was able to understand exactly what happened and explain it to us that when you multiply both sides, you have to multiply both sides by the same amount. And that's what Jesse was saying, essentially multiplying it by itself. Now, why did she choose 3 over 2? Because multiplying something by the reciprocal will cancel out the coefficient and get the t by itself. So in this scenario, we multiply both sides by 3 over 2. We cancel out the 2 over 3, and then the t is left by itself. And we simply have t equals 5 over 2 times 3 over 2, and you can simply multiply across. So really, really amazing session. Anything in general, Jesse, you want to say to the class about how to score as high as you did or close to as high as you did on the SAT math section?
Well, I know this is like cliche, but repetition is king, right?
Or queen.
Or queen. Repetition is kind of the best like trick that you can do for yourself. And the reason is not just because like, oh, it'll like help you make fewer mistakes and like yada yada, but mainly because when you do things a bunch of times, you come up with little like tricks for yourself. Like you come up with little strategies that, like, oh, you see this type of problem, like, in your head, like you have, you're able to remember something you did in the past. Like, it's just like a little method that you come up with that's purely yours. And that's how you understand something. When you're able to define it in a way, explain it to yourself in a way that can be kind of replicated, that's how you understand something. So that's why repetition is really important.
Yeah, amazing. And good.
That's it.
No, amazing job, Jesse. She's telling you repetition is key. And what I would say is what Jesse did in one of the very first problems I really, really admire. She said, look to see if you can create a pattern and understand that pattern. And that will really illuminate a lot of the implications of similar types of math problems. And that's what makes Jesse so elite at math, is mostly every problem she's encountered before, and she's recognized the pattern in it that she's seen before, and she knows how to address that problem in the most efficient fashion. I'm without a doubt, I have this company, but Jessie is the mathematician on my staff. She is better than me at math. And the reason why she's better than me at math is because she's more effective and more efficient. She knows how to get to the answer quicker than me. And that is literally a product of how much she's done the problems. Like she was saying, repetition. And when you do the problems over and over again, you start to get faster at it. It's like the game Guitar Hero. You play that game over and over again, you're going to start strumming it super fast. That's kind of how Jessie moves through math. Now, at the same time, you can't move too fast because then that leaves room for careless error. So it's that perfect balance of knowing how to do things in the most effective way, but doing it at a proper pace where you're always checking yourself and making sure that you've gotten all the correct answers. So I don't know if anyone agrees with me, but I think this was the best session yet. I've learned a lot. It was really great to go through the problems individually, and we're just going to keep getting better from here on out. So thank you so much, Jessie. You did amazing as always.